In Chapter 1, Lesson 2, Part 3, I'm going to demonstrate to you how to use the product and quotient of powers property combined to simplify expressions. So we're going to be using everything you learned in Lesson 2, Parts 1 and 2, but again, just combining those two rules together when asked to simplify expressions. So using the properties to simplify expressions, we have a certain order that we're going to follow. Just like there's order of operations in regular mathematics, there's order of operations when applying these properties. So first, you are always going to, if having to apply the product and quotient of powers rules together, you're going to always apply the product of powers rule first, then simplify as much as you can. Then you're going to apply the quotient of powers rule, then simplify as much as you can. And then step 5, which you won't be asked to do much on your assignments, is to evaluate or solve. Many times I'm just asking you to simplify, especially if variables are involved, because if you don't know the variable of a variable, you cannot solve the problem. So on this page, we have an example where we are going to apply both the product of powers and the quotient of powers to simplify all the way down to one expression. I know right away at the beginning that I'm going to be able to simplify this down to one expression because my base for every single expression is 3. So just like I stated on the last slide, when we are dealing with both the product and quotient of powers, you're always going to apply the product of powers property first. You want to do that so that you can combine what's in the numerator and what's in the denominator together. So in this example, 3 to the 5th power times 3 to the 8th times 3 to the 3rd, we're going to apply the product of powers rule by just adding the exponents on top. And same thing you're going to do in the denominator is keep the base of 3 and add all your exponents. So in your numerator, we have our base of 3. And when we add 5 plus 8 plus 3, we get our exponent of 16. And now in our denominator, we have the base of 3 again. And 2 plus 5 plus 1 is 8. Now, again, because I still have that same base of 3, I can use the quotient of powers property. Quotient of powers property says that all I have to do to the exponents is subtract because I have the same base. So 16 minus 8 equals 8. So my problem simplifies all the way down to 3 to the 8th power. You could evaluate this by doing the multiplication of 3 times 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 3. But again, unless you are specifically asked to evaluate in the question, your job is to simplify. So on this page, again, I'm just showing you where you will apply the both product and quotient of powers because you have the same base being used over and over again. In this case, it's 1/2. So you're dealing with double the amount of fractions here, but the rules don't change. First, you're going to apply the product of powers property to the numerator by adding all 3 exponents and keeping that base of 1/2 here. And then do the same to the denominator. Add all the exponents, 4 plus 3 plus 2, and keep the base of 1/2. We're going to simplify by adding all those together. So in our numerator, you'll get that exponent of 12. In the denominator, you'll get the exponent of 9. So now, because we have one expression in our numerator and one expression in our denominator with the same base, you can use the quotient of powers property here and subtract your exponents of 12 minus 9 and simplify with 1/2 to the 3rd power. Now I'm going to demonstrate or show you a little bit more difficult example here, and that's only because we are adding these coefficients or the numbers in front of the algebraic terms. It's not any more difficult in the steps that you take. The only difference here is you're going to add that extra stepping of regrouping the numbers and the factors with the same bases first. So you're always going to separate everything out. So first, we're going to take this 2a to the 6th power, make that 2 separate, and the a to the 6th put off to the side. 3a to the 3rd, put the 3 by itself, and the a to the 3rd over here with the other a. And 4a to the 2nd, put the 4 with the other numbers, and the a squared with the other terms. You'll do the same with the bottom. The only difference here is you have a to the 3rd power. Remember, if no coefficient is there, a 1 is implied. They put it here in front. It's really not necessary because 1 times anything is itself. But again, we're separating all the terms, separating the coefficients from the algebraic terms. So now you are going to start doing the math using the product of powers. Please remember that with all of your numerical terms, you're just going to do the math and multiply. So 2 times 3 is 6. 6 times 4 is 24, which is where they get this 24 from. And now we add our variable of a and add the exponents 6, 3, and 2, which will turn into this 11 here. And then 1 times 3 times 5 is 15. And 3 plus 4 is 7, plus 2 is 9. In this example, they don't explain it very well, but they started to simplify the fraction, the numbers 24 and 15 already, by dividing 24 and 15, both by the greatest common factor, which in this case is 3. So that's where the 8 over 5 comes from. It is definitely okay to leave it as an improper fraction. I'd rather have an improper fraction in this case than a mixed number, just because it might throw you off a little bit. So after you've simplified that, we still have these two a's here that we can apply the quotient of powers property. So I'm going to keep the 8/5 on the outside because I can't simplify that anymore. But I'm going to apply the quotient of properties by keeping my base of a and doing 11 minus 9. So my final answer here is 8/5 a squared. All right, now let's do some practice with these properties. First, in this example, I have the same base in the entire problem of 8. And it's in a fraction, but since I have multiple expressions on the top and bottom first, I will always apply the product of powers. So I'm going to handle my numerator first, keep my base of 8, and add my exponents of 8 plus 2, and I can't forget the 1 that's hiding there. And then I'll do the same thing to my denominator. 8, 4, plus 2, plus 3. I'm going to simplify in this next step by just adding those exponents. So in my numerator, I'm left with 8 to the 11th power. In my denominator, I have 8 to the 9th power. Now, because I have the same base in my numerator and denominator and only one term of each, I'm going to apply the quotient of powers property. So what that tells me is I'm going to keep my base of 8 and subtract my exponents of 11 minus 9. And I simplify by doing the subtraction and wind up with 8 squared. Okay, now let's try a couple more. Here we have one with decimals, 35 hundredths raised to various exponents. As always, I'm going to apply the product of powers first. So I'm going to deal with my numerator and denominator separately and I'm just going to write this up here so I have more room. 0.35 or 35 hundredths in correct mathematical terms, with 8 plus 7 plus 3, and in my denominator, the same base, 35 hundredths, and add the exponents of 3. I'm sorry, that first one is 5 plus 2, and there's the 3. Now I simplify by doing my adding. So 35 hundredths to the 18th power on top, and 35 hundredths to the 10th power on the bottom. Feel free to enlarge your screen if you're having a little trouble. I have a small space to write. So now, after I've simplified, I can apply the quotient of powers property. And have 35 hundredths to the 18th minus 10th power. And simplifying by just simply doing the subtraction is 35 hundredths to the 8th power, since 18 minus 10 is 8. All right, number 36 here. We have a lot to write, so I'm going to write it off to the side over here, just because I want to have enough room for all these steps without scrunching it too much for you. So first step, because I do have coefficients and variables, I'm going to regroup. That means I'm going to break it down, separate the coefficients, and separate the variables. So I'm going to first have 1, and then I'm going to put my x cubed over here. I'm putting the 1 just so I know I'm separating it at the right time, times 8 times x squared times 18 times x to the 9th. Same thing on the bottom. Separate those coefficients from my variables, and I'll have a 2, and that variable tied to the 2 was an x. I want to remember to put that exponent of a 1 there, just so I don't forget to add it. Times 6. And the algebraic term that was attached to that was x to the 7th. And then times 3. And my last algebraic term is x to the 5th. So now I can start doing the math. My next step after regrouping is to use that product of powers. So first I'm going to actually multiply my numeric term. 1 times 8, of course, is 8. And then 8 times 18 is 144. I'll keep my base of x to the 3rd plus the 2nd plus the 9th. And then on the bottom here, 2 times 6 is 12. 12 times 3 is 36. Keep my base of x, 1 plus 7 plus 5. Okay, and now I'm going to simplify that. This is my next step in the simplifying. So first, to simplify, I'm actually going to, I'm going to keep 144 over 36 because I know I can make that smaller. And the next step, gotta extend my line. X to the 3 plus 2 is 5, plus 9 is 14, and 1 plus 7 is 8 over 13. All right, so now I'm going to apply the quotient of powers rule. So all I'm going to do here is I'm going to separate my coefficients, and do 144 divided by 36 times x to the 14th over x to the 13th. And 144 divided by 36 is actually 4. It breaks down to a whole number. X to the 14th divided by x to the 13th becomes x to the 14th minus 13th. Okay, and we're simplifying with the quotient of powers rule, and we get 4x. If you want to add that 1, because 14 minus 13 is 1, that is completely up to you. So that is the lesson for using the product of power and the quotient of powers property together to simplify. Don't let it overwhelm you because it is multiple steps. Just follow everything in order and use what you know, and you'll do just great.